What is the value of the blue area? Properties of right triangle, rectangle, line constructions, and Pythagoras' theorem are used to solve this question. Let O, G, and C be the centers of large, medium and small circles, respectively. Also, R be the radius of large circle. Label points B, E, P, W, J, T, K, and Q. Join line C, D, line O, B, line C, E, and line O, C. Since line C, D equals to line B, E, it is because opposite side lengths of a rectangle are equal. Using Pythagoras' theorem in triangle COD, the square of line B equals the square of line O, C minus the square of line OD, which equals to the square of line CD. Substitute values and we have that the square of line B equals the square of the sum of R and 4 minus the square of R minus 4, which equals to 16 times R, after simplification of substituted values. Hence, the square of line B equals 16 times R. Take the square root of the equation. It implies that line B equals the square root of 16 times R, which equals the product of 4 and the square root of R. The result is equals to line CD. We call it equation 1. Also, join line CG, line EK, line GP, line OT, line GW and line GQ, where line CG equals the sum of 4 and 9, which equals to 13. Notice that the length of line GQ equals 9, which equals to the length of line JK. It is because opposite side lengths of rectangle JKQ are equal. Consider triangle GJC. Line EK equals line BT, which equals to 2 times R. This implies that line CJ equals to 2 times R minus 13, after simplification of substituted values. Using Pythagoras' theorem, the square of line J, G equals the square of line C, G minus the square of line CJ, which equals to 52 times R minus 4 times the square of R, as shown on the screen. Take the square root of the equation. It follows that line JG equals the square root of 52 times R minus 4 times the square of R, which equals to line EP, that is equals to line KQ. We call it equation 2. It is because opposite side length of a rectangle are equal. Join line OG, where line OW equals line OT minus line WT, which equals to a minus 9. From triangle GOW, line OG equals the sum of R and 9. Using Pythagoras' theorem, the square of line GW equals the square of line OG minus the square of line OW, which equals to 36 times R. Take the square root of the equation. Line GW equals to the square root of 36 times R, which equals to 6 times the square root of R. We call it equation 3. Recall that line GW equals to line QT, which equals to 6 times the square root of R. The reason is that opposite side lengths of a rectangle are equal. Hence, the sum of line BE and line EP equals to line QT. Substitute values and we have that the sum of 4 times the square root of R and the square root of 52 times a minus 4 times the square of R equals to 6 times the square root of R. Combine like terms. We have that the square root of 52 times a minus 4 times the square of R equals 2 times the square root of R. Square the equation as shown on the screen. This implies that 52 times a minus 4 times the square of R equals 4 times R. Combine like terms. 52 times a minus 4 times a minus 4 times the square of R equals to 0. It follows that 48 times a minus 4 times the square of R equals 0. Factorize. Hence, the product of 4 times R and 12 minus R equals 0. We have that 4 times R equals 0, or 12 minus R equals 0. Hence, R equals 0 or R equals 12. R equals 0 does not exist. It implies that R equals 12. Therefore, blue area equals the square of R, which equals to the square of 12. The final result is equals to 144 square units.